we're going to start our 11th unit and final unit of the school year. It's all going to be about surface area and volume of three-dimensional figures. Three-dimensional figures meaning they will be figures that have length, width, and height. Before we get started in this, let me kind of bring up a few things that I guess the big ideas that we're going to have in this unit. First of all, we're going to look at what the intersections of a plane and these solids or three-dimensional figures would be. So if we cut a plane through them, what you would get. Another one's going to deal more with measurements and calculations, and that's going to be finding the surface area and volumes of these three-dimensional figures. And then finally, we're going to end up with similarity again, where we take two figures that have the same shape but possibly different sizes, similar three-dimensional figures or similar solids is how they're sometimes called, and see how those things relate. See if we can calculate the surface area and volume of a smaller or a larger one, knowing the surface and area and volume of a similar figure to it. But before we can talk about all of those things and do these larger calculations, we need to get some vocabulary under our belt, and that's usually where we start. So let's just tear right in. This will be our first unit or our first section of Unit 11, our surface area and volume unit. So three-dimensional figures, that's where we're going to start. These three-dimensional figures are quite often called solids or polyhedron. There's that prefix poly again, poly meaning many. So we could have many angles, many faces, many sides, many edges, but making up this three-dimensional figure. Definition of a polyhedron is it is a space figure or three-dimensional figure whose surfaces are polygons. If you take a look at this figure that I have drawn right here, all those faces looks like the ones around the outside, left, right, front, and back are all rectangles. And then the top and the bottom look like squares. Now, without having the dimensions, we don't know that for certain, but every one of those is a polygon. Poly meaning many, gon meaning angled. So a many-angled and many-sided figure. You can see in the pictures below, they can be made up of triangles, squares, rectangles. Looks like there's a pentagon there. So they can be made up of many, many sides and many different shapes. So just polygons are the surfaces, and it's a three-dimensional figure, which means it has length, width, and height. Each polygon is called a face of the polyhedron. This one that I have drawn just to the right of all these definitions, the face would be like the front. There I've colored in the front face in blue, highlighted the top face in green. Each one of those is called a face of the polyhedron. We also have edges. I bet you would probably be able to guess very easily what an edge is. If I ask you to highlight one, you'd probably pick out any one of these. An edge is a segment or a line segment that is formed by the intersection of two faces. So the front face and the bottom face intersect in that green highlighted edge. The top face and back face intersect in the pink one. We'll do one more. The front face and the face on the right intersect in, it doesn't come out really wide there, intersect in that edge. So every time you get the intersection of two faces, you get an edge. And then finally, the word vertex, we've had that word over and over. Those are the little points where three or more edges intersect. So here's a vertex, here's a vertex, here's a vertex. There's several vertices is plural. Each one is a vertex. So several of those. Some of those words we've used before. Some of those words we've used and we really didn't make it a definition. So the more involved, I guess I could say, your picture is, more difficult it is to count them. But what we're going to do is we're going to practice counting the faces, the vertices, and the edges. All right, so let's start out with this one with a triangle. They're actually called prisms, by the way. If they don't come up to a single point, we call them prisms. So this first polyhedron is a prism, and it's full of triangles. So we've got a triangular prism is what that's called. All right, let's count the faces. All right, we have the one in front. So there's one. Front. Let me write it out to the side. We have the one in back. So the one in back's here. The one in front is right there. And then we have the left side. We have the right side. And we have the bottom. I know when I'm writing on this, the three-dimensional space, it's a little hard to see. So around the left, the right, and the bottom, kind of walk around the triangle. So there's 3, and then we have the front and the back. So there are 5 faces in that one. And you practice counting these yourself as you go, okay? All right, let's count the vertices. That might be a little bit easier. That's each one of these little dots. So here's 1, 2, 3, 4, 5, 6. 6 vertices. My pens are really narrow, sorry, while I change these. 6 vertices. And then let's count the edges. All right, here we go. I'm going to go around the triangles first. So here's 1, 2, 3. In the back, 4, 5, 6. And then we'll get the ones on this around the outside. 7, 8, 9. So that triangular prism has 5 faces, 6 vertices, and 9 edges. It takes a little practice, but you'll get real good at this. All right, let's do the rectangular prism. That's the second one. All right, here we go. Let me double check all of these. All right, let's do the faces. I'm going to go around the outside. So I'm going to go left, front, right, and back. So there's 4. It goes all the way around it. And then I have the top and the bottom. So how many is that? Well, it's 4 around, and top and bottom, 5, 6. Count the vertices. Let's do the top ones. 1, 2, 3, 4. And now on the bottom, 5, 6, 7, 8. And then finally, let's grab the edges. I'm going to go up and down first. 1, 2, 3, 4. And then the top, 5, 6, 7, 8. And the bottom, 9, 10, 11, 12. All right, let's go to the next one. Count the faces with me, okay? And by the way, this is 1, 2, 3, 4. There are 5 sides. That top is a pentagon. So we call this a pentagonal prism. Pentagonal prism. This one was because you see triangles in there, that's a triangular prism. And we've got rectangles on this one, so it is a rectangular prism. They are all considered polyhedron, but when we throw these extra, more descriptive words in there, we just have we have a better description of it, I guess I would say. All right, I'm going to count the faces. I always find it easier to go around the outside edge first. Okay, so I'm going to number them. Here's 1, 2, 3, 4, 5. That's the pentagon, so 5 faces all the way around the outside. And then the top makes 6, and the bottom makes 7. You will find a system that you think is easiest going around the outside, and then the top and the bottom always is easiest for me. All right, the vertices. Let's go around the outside. 1, 2, 3, 4, 5, just like the number of faces. And then the top, 6. So, you know what? Sorry about that. Wake me up. Actually, if you notice what time it is, it's kind of late. So let's count the vertices like I'm supposed to. Okay, that's the points. Let's try it again. 1, 2, 3, 4, 5. Now the ones on the bottom. 6, 7, 8, 9, 10. 10 vertices. Now let's go for the edges, which is what I was trying to do a minute ago. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Boy, there's a bunch there. All right, and finally, the last one. 1, 2, 3, 4, 5, 6. It may not be a regular hexagon on the top and the bottom, but it is a hexagon. So this is a hexagonal prism. All right, let's do some counting. Let's count the faces. I'm going to go around the outside first. 1, 2, 3, 4, 5, 6, because they're hexagons. And then the top makes 7, and the bottom makes 8. Let's count the vertices. 1, 2, 3, 4, 5, 6, and then the other end. 7, 8, 9, 10, 11, 12. Do you notice how much easier it is if you're coloring on the picture at the same time? All right, and then the edges. 1, 2, 3, 4, 5, 6. We go around the outside. 7, 8, 9, 10, 11, 12. And then the other end. Where am I at? 13. Oh, we have some that are hiding. 14, 15, 16, 17, 18. It also makes it a little more difficult to miss an edge if you're coloring on them at the same time. Now, take a look at the chart that we did. I want you to look at the sums of the faces and the vertices. Take a look at those sums. 5 plus 6 is 11. 6 and 8 is 14. 7 and 10 is 17. 8 and 12 is 20. Compare that to the number of edges. Compare the 11 to the 9, the 14 to the 12, the 17 to the 15, and the 20 to the 18. Do you notice a pattern? Hopefully you did. And you see that this sum that we got in here is always 2 more than, the number of edges. Now that's working on every one of these prisms. I want you to try this counting on this next group. Now, these were called prisms that we looked at. The next group are called pyramids, and they're called pyramids because they all meet at a point. They're still three-dimensional figures, but they all meet at a point up top, and that's why they're called pyramids. I'm going to pause this video and actually make a separate one here in a couple minutes, but we're going to pause this, and you hit the pause button, and I want you to see if you can fill out the chart. And you figure that out, you fill it out, and then you unpause it, or start the next video, I guess is what we'll do. Have you start the next video, and it will show you what the answers are.